Hello viewers, welcome to yet another exciting episode. Previously, we covered content on equipment at consumer intake point, and I believe I was able to give you enough content on how to do wiring at the consumer intake points. In our today's video on domestic installation, I want to take you through the content on final circuits. And as I explained in the previous video, the final circuit is any ongoing circuit from the distribution board with an intention of supplying electrical power to the electrical loads. And this power or electric current can be supplied directly from the distribution board to the load, or it can be supplied through a socket outlet, or it can also be supplied through a fused spar. A spar is an extension from the main socket outlet, radio or ring, with an intention of fusing. We know, like for example, equipment, we have delicate equipments in electrical like cooker units and washing machines, and sometimes to avoid having them destroyed by overcurrents or overload, it's necessary we fuse them separately from any other equipment that is using socket outlet. So in many socket outlets, or in many wirings of socket outlet, we tend to do an extension from the main socket outlet radio or ring for the purpose of fusing, and it is that extension from the socket outlet that we call spar. So we have different types of final circuits, and as I have explained, we have final circuits that supply load directly, like lighting. Lighting supplies load directly. We have final circuits that supply load through socket outlets and spars. Also, we have other final circuits like instant water heaters, which supply load through switches. We also have final circuits feeding motors, among many others. Even we have final circuits feeding discharge lamps. Those are just some of the examples of final circuits that we have. So in previous video, I explained what IE is, and I gave you IE regulations concerning switch gears at consumer intake point. So this institute also has regulations on how final circuits should be dealt with. So one of the regulation is that each final circuit in the distribution board should have protection against excess current, and this is where you find that lighting has a circuit breaker which is rated in many cases 5 amperes. The circuit that is controlling the socket outlet also has its own circuit breaker or fuse, which is in many cases rated at 2 amperes. The circuit that is controlling instant water heater or the shower also has its own circuit breaker that is rated in many cases either 15 amperes or 20 amperes. And the circuit that is controlling cooker unit has its own circuit breaker, which is in many cases rated 40 amperes. So that's what we mean when we say that final circuits, each final circuit should have protection against excess current. The regulations also state that or require that all final circuits should be wired separately in the distribution board, such that the circuit that is controlling lighting is wired by different wires from the one that is controlling socket outlets, and also the one which is controlling socket outlet is also wired by different wires that are with the circuit that is controlling cooker units, all the way to all the final circuits that have been connected in that installation. And this is for the purpose of testing. We do not want, when we are testing, we are compromising healthy circuits when we are just testing one final circuit. So we want, during the time of testing, if our problem or the faulty circuit is only the circuit that is controlling light, we just want to test the circuit that is controlling light without compromising other circuits, and that's why we wire them differently. We are going to look at the cable sizes of each final circuits in another episode. The IE regulations also require that every circuit in the distribution board is also controlled differently. We have talked of excess current protection. So lighting circuit should be controlled differently from the socket outlet. The socket outlet should be controlled different from the water heater, and that's why I have mentioned different control fuses for each final circuit. So IE regulations also requires that every fuse or every circuit breaker or every control gear, every switch gear should be connected at the phase conductor. And I'm going to explain why switch gear should be connected at the live conductor. Number one, we should know that live conductor is the conductor that carries current from the source to the load. A neutral conductor is the conductor that does the vice versa, that carries current from the load to the source. So neutral conductor is at zero potential. Neutral conductor is at the same potential with the earth conductor, and that means that when you are stepping on the earth, we know that the human body is conductive because of many factors within the human body that are conductive. We have salts, our body is wet, and therefore we act as conductor. So if you come into contact with a neutral conductor, I've said that neutral conductor is at zero potential. So earth conductor is also at zero potential, and the earth itself is at zero potential. So if you are holding a neutral conductor which has no return, which has no power, maybe which is not connected to the load, it means that there is no current which is at that conductor, because I have said that neutral conductor carries current from the load to the source. So if the neutral conductor is not connected to any load, it means that there is no current which is being carried. But even when the live conductor is not connected to any load, it is assumed that it is getting power from the source to the load. So when you touch a live conductor, you become the load. The current starts flowing through you, then through the ground, then the ground becomes the neutral conductor, and that's how a person is electrocuted. That's why we put switch gears at the phase conductor to make sure that even when the switch is off, the other part of the circuit is not having any current, and therefore you cannot be electrocuted. Number two, if switch gears were to be installed at the neutral conductor, there are chances, very high chances, that the circuit will work, but it will be a very risky circuit. Why? In any case, if the live conductor or if the load gets into contact with the earth and it is well connected to the live circuit, it is going to operate, because you have also said that earth is at the same potential with neutral, so earth will act as a return wire, so the switch will be useless. That is number one. Number two, it will be very hard for you to do repair in that circuit, because for repairs to be done, you have to put off the switch gears, and if the switch gears that are controlling the circuit at the neutral conductor, then the live is still having some current, and as I have explained earlier, the live carries current from the load, from the source to the load. So when you will be touching the live wire, it will electrocute you. And those are the reasons why switch gears should always be connected at the phase conductor. So for today we can stop there. In the next episode, I'm going to explain you how to connect each and every final circuit in domestic installation. And remember, we said that after this episode, I'm going to expose one of my projects that I have done and has not been presented by anybody.